Jordan Lask, founder of Demergent Labs, creators of Azel, Kybra, and Pseudograph, come on up here. We're really stoked to welcome you to the stage.
Okay, you can hear me just fine? Sweet. So it's going to be kind of a fireside chat. Tell me about yourself, Jordan. Just kidding. Okay. By the way, this has a laser pointer, which I'm actually going to use. Few of you have heard this story before. I want to give you just the background on like what brought me to the ecosystem. For context, well, I'm going to give you all the context. Then I want to tell you where I'm going. Demergent Labs, that's my company. We're a team of 3. We're building fundamental open source developer tooling. And I think we have possibly a good idea that I really want to run by everybody. I'd love to talk to you about it and get your feedback afterwards. So early days of my life. For context, I was born in 1991, so the 90s were my playground. I always had this, for some reason, incredible fascination with digital technology. I think a lot of it comes from my dad. He was a software engineer, and we lived in Silicon Valley at the time. And so everything he did to me was just super amazing. And it just gave me this joy. Probably a lot of you feel this way. The ability to create something just brings you joy. And for some reason, digital technology, and especially the internet and the web, I could sense that there was this incredible latent power in them for some reason, right? And obviously, it has absolutely revolutionized the world in many good ways, in some incredibly bad ways as well, unfortunately. I'm an American, grew up in California. I've always been drawn to the principles of freedom that are enshrined in our founding documents and such, which also just fascinates me. Yeah, there we go. And kind of like a common thread as I start to get older and play with technology and get into my degree, which was computer science, was this idea of permissionless innovation. For example, I would always download all these crazy programs and stuff on our family's computer, and like my parents would be like, "Stop doing that," because it like would bring all these viruses. But as a kid, because you don't have any money whatsoever, if I ever had to pay for anything, it was kind of like a non-starter. And my dad told me, "Hey, did you know there's this thing called open source? Like there's software that people actually give away for free." And I was like, "What the heck? That's amazing." And then web programming, like as a kid, I always tried to program. My dad had like this book, like the C Bible or something, and I could do like the first chapter, and then my brain exploded because it was just too hard. But web programming, I knew, I just could feel it, that I didn't know the technologies behind it, but HTML, CSS, JavaScript, the fact that as a kid I was sitting at our family computer and like chatting with people, you know, who knows where it was like Yahooligans. It was like for kids, so it wasn't crazy, but like it just felt so powerful. And permissionless innovation, like when somebody builds an open source library, they basically give you they give you a license to basically do whatever you want with it. They're not trying to control you and do all these things. Web programming, you can just create anything from your home. DNS, again, I don't really have to ask permission. Yeah, you have to sign all of these things and stuff, but generally it's open. And I can have a name that I can attach to like a web hosting service. This is what I did. I would open up Microsoft Word. I had no idea what was going on, but I knew if I put like pictures of Dragon Ball Z in there and like wrote all this stuff, I could export it as HTML and throw it onto our like Comcast free web hosting, and it would assign me like a subdomain. And then I literally, as this kid, had a website that was available to everybody with internet access. That was amazing. Oh, and I remember we were driving through like Santa Clara or something one day, and I saw a building, and the Yahoo logo was on the building, and it blew my mind. I was like, I thought Yahoo was just some like random person like me, but it changed my world when I realized like this is actually a big deal. Like there are companies that are doing this kind of stuff. And I feel like a common thread to all of this is decentralization, right? Like especially the early web in the 90s, I feel like it was in many ways all about decentralization. And I was no special person. I mean, being born in the United States, having a software engineer's dad is pretty cool, but whatever, I just was a normal elementary school kid. And which leads me to my choice of career path, software engineering. It just sounds better than like computer programming. So I started an ed tech company with Bob Bodley. We went to the same university. I was tasked with the entire stack of our software. So full stack, right? Front end, back end. What languages are we going to use to build the UI? What languages, frameworks, databases are we going to use on the back end? And if you don't know, it's extremely complicated to do all this, especially if you want to design for any sort of scale. Turns out we probably could have done everything on like one EC2 instance, but I was planning for massive scale. And to do that, you just have to go down these crazy rabbit holes and try to figure this out. And then, in later companies, because that one didn't quite work out, we worked on it for a couple years, made a little bit of money. But AWS configuring everything with the load balancers and dealing with all your ports, and it just gets very, 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 very complicated. Around that time, right, basically the last year of university for me, I discovered Bitcoin and Ethereum. For context, this is 2017. I was in a distributed systems class. So what is a distributed system? There are some problems in the world that cannot be solved with one computer or one process. It must be solved by coordinating many processes together. That's what this class is all about. And I had this feeling, that same feeling I had as a kid observing web programming and JavaScript. This latent power, I felt it with Bitcoin and Ethereum. When you study Bitcoin, in many cases, I think it inevitably leads to Ethereum. That's what happened to me. And it seemed like these were possibly the ultimate distributed decentralized systems. At least they had that feeling, as if they were maybe headed in that direction. And what was even more beautiful is that it was open source, entirely open source, and not just a front-end library or a back-end package. It was like the entire hardware and software stack was open source. I didn't have to go to AWS, give them my credit card, give them all my information, read their silly, ridiculous terms of use that go above and beyond like the laws of the land, which is kind of sometimes arbitrary and annoying. It's just open source. You just have a license and you can use it. And that to me was very powerful. And a common thread, or something I really started to learn in the university, was the power of protocols. For example, the internet stack. What is it? It's just a bunch of protocols. What's that? It's just software that codifies some rules that basically allow processes to communicate with each other and perform a task. And Ethereum and Bitcoin are protocols. And that's beautiful. The internet, like I said, protocols. And just to point out here, like Bitcoin and Ethereum and the whole crypto space is entirely fascinating because it's weaving all these things together. In some ways, they are the heirs of the internet. They are the next generation internet protocols. There's so much fascinating economics going on in the space. There's philosophy. There's politics and freedom. There's libertarianism. There's maybe more progressive type things where you want equality among people. It's an absolutely fascinating space, which leads me to discovering DFINITY. I think this is how it happened. I've told a lot of you this before, I think, but I think I was in my dorm room. I think I was in my bed. I think my feet were dangling over. I wasn't laying down. I was on my phone, Googling not random, but trying to learn as much as possible about the blockchain space. And I think DFINITY just came up in my search result. Clicked to their website, read it. Oh, that seems pretty cool. Then basically downloaded every podcast I could, every interview with Dom, and it's really his vision that has kept me here the whole time. He talked about things he talked about blockchains in terms of a scalable virtual machine and in terms of protocols. he wasn't talking about it like other people were talking about it. And to me, it jived extremely well with basically everything I was learning from my schooling and the whole permissionless innovation, the idea of protocols. I mean, this guy got it. I mean, I got what he was saying, and it was amazing. And this idea that he wanted to extend the internet protocols to provide something that they never provided before. The internet protocols are stateless. It's all about communicating data. You just send data packets from one process to another process anywhere in the world. You don't do anything else. Compute and storage are not in those protocols, and thus we have this entire industry with mega monopolistic companies to provide the compute and storage in a proprietary way. But Don was talking about it. No, we could actually do that as a protocol, something open and not owned or controlled by one single entity, a true logical world computer. Not one physical computer, but a logical computer. What is that? One computer made of many different computers, basically. That's the internet computer. That is the implementation of Dom's vision. This is what the DFINITY Foundation worked on and continues to work on for years. Again, it's that vision of a world computer where Bitcoin and Ethereum lack. And by the way, the internet computer has trade-offs just like Bitcoin and Ethereum have trade-offs. They choose different sets of trade-offs. But yeah, in many ways, I think the internet computer has an excellent vision that goes above and beyond almost anything I see elsewhere. No one has this vertically integrated full suite of a decentralized computer, not owned or controlled by any single entity. It's been a difficult road. I don't know about you guys, but I am somewhat surprised with how difficult adoption is. I've been following the space for about 6 years, like DFINITY. Some people have been here even longer. Maybe I'm just naive, but it has been a little bit difficult. I think business models and traction are somewhat elusive for a lot of projects. Open source infrastructure, which is incredibly important. I mean, a little thought experiment. Just snap your fingers, imagine, and delete all open source software in the world. What would happen? A black hole would form in the center of the Earth, and it would engulf us all. But it would destroy like everything. Like commerce would just come to a halt, and we'd have to rebuild and form tribes and everything. So that'd be crazy. Right now, it's all funded by grants from the DFINITY Foundation. That's not. I mean, it's sustainable to some extent, but it's not like a scalable, sustainable business model for providing your open source infrastructure. So we'll get into that in just a minute. But Demergent Labs is my company. What are we doing? We are accelerating the adoption of Web3, the internet computer, and sustainable open source. It is one of my personal goals to find open source native business models. What does this mean? A business model that doesn't require you to change your license. Just the traditional OSI business licenses, MIT, Apache, BSD, all those. I want to be able to write software, push it out, and just capture the value that creates, because open source software is possibly the most valuable software ever created, and yet it's very difficult to capture the value. We're working on ASL. That's a TypeScript canister development kit. We don't believe you should have to learn a new proprietary domain-specific language necessarily to work on a general-purpose computing platform. JavaScript and TypeScript tie with Python for the most popular languages in the entire world. Python is our other project, also a canister development kit. Together, there's like, 20 to 30 million developers. Pseudograph is our GraphQL database. GraphQL is another one of these technologies that I think is just extremely beneficial in the Web 2 world. So, I mean, we're working full-time on these things, and basically, right now, we're just working on ASL and Kybra. Incredibly difficult, but they work. They're in beta. They basically have the entire Internet Computer API stack available to you, and we're working hard to get as many NPM packages, as many Python packages as possible to be deployed, so that you just write Python, pull in your package, deploy it, and it just works. Yeah, like just bring the dev tools people already know and love, just bring them over. That's our whole thesis here. Okay, so that's just the background. I just want you to know from a person like me who suffers from the mental disorder of being a programmer, right? That's how I see things. Now, where am I headed? Look, I love what I do. I basically have my dream job. We have a large grant from the DFINITY Foundation that gave us a runway to just build open source tools, to not really worry about anything else and just build it. And that's a dream. But, we want to unlock barriers of adoption to the internet computer, obviously. And I think open source software is one of the best ways to do that. Not everything is an app. There's so much, between the protocol layer and the app layer, there's so much that needs to be built. And I would love to keep building that. And I want to make this sustainable. What happens if we don't get another grant? What happens, I really want to avoid going down the VC route if I don't have to, because I don't want to bring all that extra baggage along if I don't have to. I'm living the dream right now. I'm writing open source software and just pushing it out there and getting paid. Like, what could be better than that? Which leads you, me, and us, all of us, to this idea that I would love to get your feedback on. And let me try to explain it simply and in detail for us here. It's called cycle compensation or cycle sharing, or there's a few other names. I don't know what the best name is yet. And I just want to emphasize that this is potentially a very unique value proposition of the internet computer that would be very, very difficult to do on traditional cloud platforms and possibly on other blockchains as well. But to give you a little bit of background, other blockchains are experimenting with this type of idea under the name of contract secured revenue. There's a project called Conto that has this. Near has something like this. And EIP 6969 was just introduced on the Ethereum Magicians Forum to, they're discussing it there to see if Ethereum layer 2s might want to do something like this. So there's a little bit of prior art. And the idea is that you don't burn all cycles. So on the internet computer, all computational resources and all storage are metered through an asset or a unit called cycles. And basically you burn cycles as your application or your canister that does stuff, basically. And right now they're all burned. And burning means they just disappear, they're non-existent, they're gone. Well, imagine if instead of burning all the cycles, a small percentage were distributed. They kept track of, I think it'd be best to do this at the protocol layer, but imagine they're kept track of somehow, and they're distributed to all of the dependencies of your canister. That is the basic idea. And I think it's very, very important that this be something that is voluntary. So you could opt out of it. You could change the percentage of the compensation that you want to give. And I think what makes this absolutely killer compared to other donation and voluntary models is the extremely low friction. The cycle burning or cycle payment model is already adopted by every application on the internet computer basically by default, right? And if this were switched on, it would make things, that percentage, more expensive, but there is no cognitive overload to the developer. There's no, you wouldn't have to go opt into it necessarily. You could opt out of it. A lot of this is up for debate. The point, or very important to this, is that developers would be able to configure things to make it how they want, if they want to. But by default, it would simply work. To help you understand, I want to show you some. This is the best thing I've ever seen Midjourney do, by the way. Look at that. Just kidding. So this is a Ethereum smart contract in the middle. Take a look. It's using Open Zeppelin library. Open Zeppelin is one of the most trusted, amazing companies in Ethereum. Their stuff is battle hardened and like everybody uses it. So how it basically works, this is simplified and might be slightly wrong, but basically, let's say you want to call a function on the smart contract transfer, and it's going to cost you 50,000 gas times whatever the gas price is to do that. Right now, basically a portion is going to go to the validator, so to keep it simple, imagine just half. 25,000 gas tons of price would go to the validators, and 25,000 gas tons of price would be burned. Okay, imagine if Ethereum implements this type of model. Simple. 10% goes to Open Zeppelin. Why don't you get this? This is so simple. Just kidding, sorry. The validators get 22,500 gas, and 22,500 gas is burned. And Open Zeppelin happens to be the top level dependency right here. So this is simplified, but Open Zeppelin might have dependencies, and those dependencies might have dependencies. These are called transitive dependencies. So we would need to come up with heuristics for getting this gas fee down to all of those dependencies, but I think there are some simple heuristics we could come up with. And so how would this work on the internet computer? Imagine you have a canister. Here's a little ASIL smart contract. So the main dependency is ASIL. Imagine it's burning 1 trillion cycles per day. 1 trillion cycles is about like $1.30, $1.40. The protocol would keep track of that, or whatever implementation would keep track of that. And it would burn 1 trillion cycles, but then it would say, well, what's 10% of that? And it would charge that from the canister and send it to the ASIL dependency. And again, we would come up with heuristics to deal with the transitive dependencies of ASIL. Like I said, I don't think this would be easy or practical to do on other cloud platforms. Imagine how you do that on AWS. You'd need some universal metering system across all of the hardware. Well, we have that because we use WASM as our one and only compilation target, and the metering is built in. Cycle metering, like I said, is making this possible. And why I think this really fits in, philosophically, we already use ICP, and cycles come from ICP. That's the only way to get cycles. This is just extending the ICP incentivization mechanism that we already use for NNS voters and node operators. How the heck do we pay for node operation with ICP? Node operation is fundamental and core to the network. How do we pay for the governance, which some would argue is fundamental and core to the network? We do it with ICP. So why not extend it to the fundamental core software of the network? And what's absolutely fantastic about this, if it is actually a good idea, is that you make open source investable. This is a very, very simple, conservative, easy to understand model. And if you can convince somebody that based on usage, like if I make a library that's going to be used by 25% of all canisters, for example, it's not unreasonable that the TypeScript, ASIL and Kybra, that perhaps someday 50% of all canisters are written in Python and or TypeScript. So if I can walk up to an investor and tell them, hey, we're making $1 per month right now. The internet computer hasn't even scaled anywhere near Ethereum, Bitcoin, or AWS. Project out, there's an investment case, possibly. It's very simple. It's very sustainable if it works, right? This is all in theory. Okay, I'll just give you some projections here. This is not the best slide ever created. Midjourney didn't get this one right. So here we have, so left column. We have a few networks. We have the Internet Computer Protocol, Bitcoin, Ethereum, and AWS. And then we have the percent of the fees that would be given out to all the open source libraries. So let's just assume 10%, just to keep it easy. On the right-hand side, we have the total fees, like the total fees for that network. And then we have the cycle compensation or the fee compensation for open source projects. So the left-hand side is just total fees. The right-hand side is the open source revenue stream, basically. So you'll notice ICP right now, which is burning about 5 billion cycles per second. Right now, in total, we're doing $200,000 in fees per year, which is very, 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 very small relative to other networks, at least Ethereum and Bitcoin. So if we implemented this model, that would be a revenue source of $20,000 per year, which is not very much, but for one project, it could work, I guess. And then basically we just scale up. If we scale by 10x, we get $200,000 for open source. 100x, $2 million. 1,000x, $20 million. And 10,000x, $200 million per year for open source, which just sounds outrageous to say you're going to grow 1,000 to 10,000x until you look at other networks. Bitcoin, last I checked, and these are simplified, so I did some research to make sure it was relatively accurate, but Bitcoin is doing about $300 million in fees per year. If Bitcoin implemented something like this, which of course Bitcoin would never do, but that would be about $30 million for open source. Ethereum right now burns $2 billion per year in fees. There is an EIP open, not for the core layer, but for layer 2s. If they implemented this, that would be $200 million for open source, and then AWS, $80 billion in revenue. So if they were somehow able to implement something like this, it would give you $8 billion. The point is just to take a piece of the fees and give it to what's powering your library. It's a very simple concept, and I think it could be incredibly powerful. Because it's open source native, you do not have to change your license. Makes open source software possibly investable. And imagine this virtuous cycle of public goods development. If I can just write the best code possible, push it out, and if it's used the most, then I make money. That sounds like it could create an amazing virtuous cycle of public goods development. And if this truly is a unique proposition of the internet computer, which I theorize it may be, this could be the place where devs can truly come and live their dream. We could create, like open source software developer, it's kind of a career path, but for a very, very small amount of people, that could become an actual viable title that people could use. And I mean, this is just the most simple business model we've thought of. I think there are interesting tokenization models you could possibly build on top. For example, if this revenue stream is actually working, our idea at Demergent Labs would be to keep spinning up fundamental projects and possibly spin them out into foundations or DAOs or something, and give them most of that revenue stream so that they can keep doing their operations, and maybe we would maintain a small piece. So as we keep going, we spin it out, make it open, everybody has a little piece of the revenue stream. And obviously ASIL, Kyber, and pseudograph, the idea would be to implement it for these projects if possible. That's basically it. So why I'm still here, the internet computer has an absolutely amazing vision. It's an incredibly interesting piece of technology for all the reasons I said. And I want to keep building open source software and just make this dream come true for developers like you and me. So thank you.
Keep it going for Jordan last.